Hey guys, so today we're going to work with a complex number z such that z squared minus z is equal to the imaginary part of z. What we're going to do is we're going to say z is equal to a plus bi, because since z is a complex number, it is composed of a real part, which is a, and the imaginary part, which is bi. Z as a complex number can also be written as the real part of z plus the imaginary part of z times I. Now if you look, b is equal to the imaginary part of z, and the a is equal to the real part of z. The I is what makes this term imaginary, but b itself is still a real number. So this imaginary part of z is still a real number. So what we're going to do is we're going to plug in a plus bi in the place of this variable z. So what we're going to have is we're going to have a plus bi squared minus a plus bi. And this is equal to the imaginary part of z, which is b. If we simplify this, we get b is equal to a squared plus 2abi minus b squared minus a minus bi. Now what we want to do is on this right side of the equation, we want to keep the real parts together and we want to keep the imaginary parts together. So we're going to get b is equal to a squared minus b squared minus a plus 2abi minus bi. We can factor out a bi from those terms, so we are going to get b is equal to a squared minus b squared minus a plus 2a minus 1 times b times I. So now if you look at this equation for a second, we notice that the left side has no imaginary parts, but the right side does have this imaginary part. But for the two sides to be equal, we need both the left and the right to have the same number of imaginary parts. So we want to make the right side of the imaginary part, right side have 0 imaginary parts, which means either this term or this term has to be 0. So that means either we know a equals 1/2 or b is equal to 0. Now since we've established that, we can regard this little imaginary section as 0, and we can continue on with this. So continuing, we get b is equal to a squared minus b squared minus a. And from there, we are going to get b squared plus b is equal to a squared minus a. So now what we're going to do is we're going to plug in both cases of a equals 1/2 and b equals 0. First, we're going to plug in b equals 0, so that's 0 is equal to a squared minus a. 0 is equal to a times a minus 1, which gives us the two possible values for a of a equals 0 or a equals 1. So we can write 0, 0 and 1, 0 as the two possible ones that work for this. Now let's plug in a equals 1/2. So we get b squared plus b is equal to a squared minus a. This gives us b squared plus b is equal to 1/4 minus 1/2. b squared plus b equals negative 1/4. Moving that to the left side, we get b squared plus b plus 1/4 equals 0. And this is actually a perfect square trinomial of b plus 1/2 quantity squared equals 0, which gives us b equals negative 1/2. So this gives us the solution of 1/2 comma negative 1/2. So remember, these are all solutions of a comma b, but we want to find the magnitude of z. And the magnitude of z is equal to the square root of a squared plus b squared. We just plug each of those in. So for 0, 0, we get 0. For 1, 0, this will give us 1. For 1/2 comma negative 1/2, we'll get 1/4 plus 1/4. Square root of 1/2 is square root of 2 over 2. So we know that all the possible values of z, or the magnitude of z, will be 0, root 2 over 2, and 1. And that is our answer.